Okay, welcome back to episode 35. I took one day to rest up and then I decided to come back out here and work my way into getting some stuff done. Already got my hands dirty, spent some time working on the prop hardware. If any of you stayed awake until the end of the last episode, you knew that I was ordering a bottoming tap that could clean up the holes in the hub. And I was concerned about hardware length because if the bolts are too long, they were going to come back through the back side of this prop hub and into basically the alternator. When I first noticed the hardware length discrepancy, I also noticed that they were not AN hardware. Even though they were 3/8 24, they were grade 8 bolts, which is grade quality hardware, of course. But when I went to go choose the correct length, I decided to go with an AN6. And today is the forehead slapper moment when I realized that the limitation of the AN6 or any of the AN hardware is that the threaded portion is very short. These are those bolts right here. This is a grade 8 on the left, and this is an AN6. And that is when I realized why they did this, because the threaded bosses that are in the hub that they stick through are quite long. They're way longer than this. So if I did use one of these, it would shank out, strip out the hub. Not a good deal. So I hopped in the car, drove down to my local hardware specialty shop, and got some grade 8 bolts that are the correct length, in this case 4 inches. Then I got back here and I took the prop off the airplane, both sections of the hub, set it aside, got at the bottoming tap, cleaned up all 6 holes. They did need a little bit of cleanup, and then I found that they are also blind holes, or partially blind, so that's what a bottoming tap is for. But that also meant that I had to be super careful that I didn't run through. So I got all the chips cleaned out of there, and that's when I realized that the 2 short bolts, which you can't see, they're inside here, were also having the same problem. The bolts I needed are actually this long, but they needed to be all threaded because this, again, it was going to shank out in the boss that sticks out of the prop hub. So I made another trip down there. So I got some bolts which are 1.5 inches, and those are what's in there. I also got some 1.25 inches. Those are too short, but at least it kept me from making a trip back and forth. So the prop is installed, but of course I'm gonna have to take it back off in order to pull the engine off, and that's gonna happen during this break, probably in the next day or so, because I have to get the primer in the bare steel parts of the motor mount, which I had the powder coater mask off. So now I'll run this intro and I'll show you what I did for the fuel injection. Prior to heading out for work last shift, I was reading the manual and I determined that this was I believe it's a 70 micron filter. And according to the manual, I was also going to need a 25 micron filter between output side of the fuel pumps and the input side of the fuel servo, the throttle body. And of course, the reason why I needed the 25 micron filter is because we're running fiberglass tanks and we can expect them to produce fuzzy stuff which needs to be filtered out. I spent some time on the Airflow Performance website. I sent an email and I told them I also wanted to flip my mixture control and change from an elbow to a straight fitting on the fuel inlet to the servo. And the response I got back was that I really just needed to ditch the 70 micron cartridge that's inside here and use a 40 micron, and that was going to be all right. So I ordered 2 of them just because I know I'll end up servicing this thing. This is a cartridge. This is the 40 micron. The 70 micron, it's almost impossible to tell them apart. I was out in the sunshine looking at them because they look identical, and I realized there is a difference, a very subtle difference in the pitch between each of these little. I'll post up a picture of it later so it makes more sense. But anyway, so I took this apart. This requires a couple of 1.5 inch wrenches or a padded jaws and a vise and 1.5 inch wrench. Pull it apart, replace this. I got all the O-rings that are going to need. I got all the O-rings which are going to be needed to service this thing for a couple iterations. And then what I'm going to do is clean this cartridge at 2 hours, 5, 10, 20, and so forth until I'm sure that it's running clean and not sucking up any debris out of the tank. And the other project I was working on is getting from the outside of the accessory cowl with a scoop into the throttle body inlet, and I learned some stuff there. So I'll show you what I found. So this is one of the new pieces I got. There's a paper gasket which goes in between here. I don't have it in because I'm still mocking everything up. This is that fitting which I was going to replace with a straight fitting. And then of course I was going to flip my mixture, and turns out I can't buy the parts for that. I need to send my throttle servo in have them change it, and then send it back. And where the factory recommends you use a K&N filter of some kind on here, I was having a hard time finding a base, even though that seemed pretty simple. It's a square. But when I was on the Airflow Performance website buying the filter cartridges that I just showed, they had this arrangement right here, and they make a huge deal out of the shape of the inlet as the transition from the different sizes takes place. The installation manual and the website are big proponents of having alternate air. So that's what this adapter allows me to do. I can put this on here, and they want you to have a K&N filter inside the cowl somewhere, and then have this alternate air arrangement so you scoop ram air from outside the aircraft. So I'm gonna have a third cable, and this one I can rearrange any way I want, not a big deal. Then I just need to work out from the scoop on the outside of the accessory cowl into this inlet with the trapdoor. And quick review for those just joining me. This black elbow right here is the fuel source from inside the aircraft through the header tank and the fuel selector valve. I was going to run the fuel filter up here so that it was a straight shot from there into the filter, and then a 180-degree elbow back into this fitting right here, which is the fuel pump manifold. Since I want to keep everything accessible, I'm probably going to revise that to slide it down here so that there's an elbow similar to this one that goes into the inlet side of this fuel filter, and then a flexible line from here into this one. That would be pretty accessible with the accessory cowl off. And that brings me to another point, which is at one point I had this designed as a full fiberglass piece. That's preposterous because I would have to take the engine off to take off the cowl, or I'd have to have some super strategically mounted doors. So this leads me back to the first iteration of this might be sheet aluminum, pretty simple, and I may just do a fiberglass of the inlet scoop. Again, quick picture for anybody just joining. Well, I didn't have the camera running, but figured I'd turn it on right here because there's still a chance I'm going to drop this thing. The idea is I'm going to put it face down on the foam and pull the motor mount off. I'd say that didn't go according to plan, but I didn't have one. But in the end, no damage to anything. It's all fine. So I'm going to strip off the mount, which means taking off all this stuff I had temporarily mounted up here and packaging up this throttle body. Okay, well, mission accomplished. As far as getting the engine off and getting this mount back out, you can see these bare steel pockets. So I'm going to clean these up and get some epoxy primer in here. I got to figure out a way to mask it, and from this side it'd be super easy. I could just make a piece of cardboard that went around here and tape up the back sides. This side will be more challenging, trying to get access from here without shooting primer all over the rest of this. Jumping forward a little bit, the engine mount has already been taken off the engine. I did the epoxy primer on the pockets for the engine mounts. The mounts are put back together. The castellated nuts are back in place. I torqued those, and then the cotter pins are in there. So that's ready to go back on. I still have to put the firewall back on, drill hole locations for the fuel pumps, the battery contactor, starter contactor, fuel filter, some other stuff like that. As long as I was using one of those cans of the primer, the 2K stuff that only has about 48 or 36 hours once you shake it up, I sprayed this stuff. I now have 3 of these fairings for the rudder cables where they come out of the back of the fuselage. Still need to paint this white, and then the gloss clear coat on top. That got me this far. The reason I have 3 is that I had 2, stepped on 1, ordered 2 more, cut 2, so now I have 1 extra that certainly I'll screw up one of them along the way. I also primered the cross member, can't see it from here, unique to the Series 5, that goes across the back of the baggage compartment where the fabric comes up and attaches to the baggage opening on the 5 is a little bit smaller than the Series 7. So now it's time to get serious about wiring the aircraft, something I have no skills whatsoever, at least very rudimentary. A lot of this stuff is new. I've done an installation of a transponder to comm radio in my Citabria, and that went fine, came out good under supervision obviously of somebody knew what they were doing, but now it's time to wire up this entire airplane. Been a while since I've shown the schematics that I've been creating in SolidWorks, where I've drawn up every single device, the comm radio, transponder, all those kind of things, drawn them up one to one, positioned them in my CAD model. Now I'm also down to things like this is a battery contactor, so I have that drawn up. It's a primitive version of this, but it stands in, and then I run a sketch which shows every single wire, every color, the gauge of the wire. There's a pin number associated with one of the LRUs. It's on there, pretty detailed, but a schematic is the logical way stuff's put together. The actual wiring diagram is something I have yet to create because I'm still trying to visualize how that's going to go. And for a long time I was dreading this part of the process, but all the build threads and people that it got through said it was one of the more enjoyable parts of the build, so I am kind of looking forward to that. One of the things I need to install is the stab trim position indicator. So this is one of the things that came with my kit. Whether this is a rheostat or a potentiometer, I'm not exactly sure, or what the difference between those two is. But basically there's 3 wires. There's ground, power, and then there's another wire which is how much power comes back. And I did not have installation instructions for this, so I emailed Heather at Kitfox, and next day she had these instructions emailed to me. Some of the other things that came along the way, I've had them for quite a while. Probably showed them before. This is a stab trim position indicator. It's a Ray Allen RP4. Just a row of LED lights. That gets wired in. I also have the Ray Allen trim switch, which seems very light duty compared to the one supplied by Kitfox. I'm actually not sure which version this is. There's a couple different ones that have different service lives. In other words, one of them's good and one of them's not so good. This one, even though it seems heavy duty, this is pretty light duty, and the reason that works is it's been a while since I've done the segment of cool crap that just showed up in the mail, but this is the TCW safety trim, the heavy duty version, because the jack screw on the Kitfox can actually draw up to 7 amps, which is more than I have in mind, but is well within the capacity of this controller. I have the wiring diagram already done, schematic wise, for how to tie in that trim position switch that you already saw, and the 2 hat switches, which are on each of the control sticks that are already in there. So I'm gonna have all those wired in. And the trim position indicator is actually completely different, is completely independent of the trim motor. Let me try that again. So there's an electrical system, which is the jack screw that positions the stab, and the trim position indicator is wired completely separately. Technically has nothing in common, other than that they're both associated with a stab trim. Obviously we're having nice weather here today, lots of planes flying. This is one of the other components that comes with that stab position indicator. This bonds to the tube which runs fore and aft at the bottom of the vertical fin, and you mount that little device with the plunger on it to this, and then there's a tab already bonded to my elevator. Got some, this is the 3 conductor shielded wire, which is part of that trim position indicator setup. And I have some super heavy duty wire in here for the trim motor. I don't know that it's the right kind. But speaking of that, I've ordered a bunch of electrical stuff recently, and I could encourage everyone to go to the Kitfox forum. There's a thread, put a link below, Eric Page did a good tutorial on how to make some of these connections and where to get some of the stuff, like the wire, some of the tools. He actually provided links for things like this is a set of strippers, which doesn't cut the wire, it clamps the wire and it strips them just the right length off of there. These are just a simple set of trimmers to cut wire with, one strand at a time. And this is a crimper, which is used for the pins which go in the sub-D connectors. Or is it D-sub? I can never remember. It seems like I have no idea what I'm talking about. That's an accurate assessment. A bunch of 22 and 20 gauge single strand, a single conductor, unshielded wire. You saw the red here. I also ordered some black, but what showed up was 16 gauge wire instead of 20. Not exactly what I had in mind. I think I'm probably the one that ordered the wrong thing, but as it turns out, after going over Bob Knuckles' book, there is application for 16 gauge wire in my schematic, so it'll get used up. And here is something I'd not even opened the box on until just now, so big surprise for all of us. This is a power supply that can plug into 110 volt. I can set it down to 12 volts, 14, 13.8, whatever I want. And I can set the amps anything up to about 10 amps. So I can basically plug in parts of my instrument panel or the whole instrument panel mocked up on a bench and run it prior to installation in the aircraft and getting any of that excess smoke out of it. Straight off Amazon. Not very expensive, it's gonna make things pretty convenient. So now it's back to putting the firewall back on the airplane, drilling a bunch of those holes again for the fuel pump system, fuel filter, battery contactor, starter contactor, fuel, I already said filter. There's a few other things. Ground block, front and back. I'm gonna do that carefully so I don't have some holes that I need to plug up. I did have a question I put on the Facebook group the other day about running a power cable through the firewall. I had figured that since fuel has a bulkhead fitting, that electricity might need a bulkhead fitting also. And I found on Summit Racing a bulkhead fitting which seems like it'd work. And so I asked on the Facebook group and of course got every single answer to the sun, so nothing unanimous there. Some people said, yes, that's a great thing. Other people said, just use a grommet, don't worry about it. And somebody else had this super high dollar solution. Probably is the ultimate, but this is, I hate to say just a Kitfox, but simple airplane. I may drop back to the grommet idea. Least number of connections. I'm putting the battery probably right here. Need to mount a tray in there for that. I believe those are things I can purchase from the factory, but also would be pretty easy to fabricate. And gotta admit, when you make a mistake, I was gonna put in the forward floorboard today and put the rudder pedals on it, be permanently done with that. Then I realized there's a piece of fabric in the middle that I didn't bond on. I have to figure out how to unmess that up and bond that on correctly. I'll figure out how to do that, and that'll be the next video. Still got to trim the boot cowl. This engine will go back on permanently. As I've told a few people that have come by my hangar recently, if I had any idea that this had gone as smoothly as it did, I would have made arrangements to permanently install this thing the first time. But I was positive I was going to run into a roadblock that was going to require me to re-engineer it, but there wasn't any. So now I know it's going to go back on smoothly, and I can get back to work on the, once the boot cowl is on and trimmed up and mounted, then I can work on the accessory cowl that comes from there to the back of the, basically to this white ring on the mount, hopefully you can see that, behind the exhaust system. I have other stuff on order for the electrical system, a bunch of shielded wire to do the wingtip lights, the strobes that are out there, and the magnetometer way out in the other wingtip. There's some application for shielded wire elsewhere. In Bob Knuckles' book, he says there actually is not as much as we tend to think, and his book is very good about the logic he lays out for why we don't need an avionics master switch anymore, but that I do need a second, what does he call it now, an endurance bus for times when you have an electrical problem. You want to make sure you have enough power to get to your, at least the nearest destination without causing stress. I did go through and add up all of my electrical loads so that I can now choose the appropriate battery size. So I have sized my electrical system, come up with my total amps while it's running, and I can sort things out as to what should be on that endurance bus, the one that needs to be on, and then another bus that I can use to shed load, things like landing lights, USB outlets, panel light perhaps, all that. But with my prop hardware problem solved and getting this thing back on, I'm pretty sure that next month I'm going to have this thing on. I'm going to pull it out here and jury rig the oil tank and a fuel setup and fire this thing up. It'll be kind of fun. I won't go way out of my way to do it. In other words, I'm not going to set back my build schedule just so I can hear the engine fire up, but if I can pull it off, that'll be kind of cool. And in the meantime, that's probably all I got for this episode. We'll see you episode 36. Thanks for watching.